The intro showed two problems: data that loses its origin the moment it leaves the system that made it, and an agricultural data world still split into isolated networks. Here is the platform, what you do, and where each action ties back to those problems. A farmer registers their file. The platform writes one line on the shared log, the file's fingerprint, who registered it when. The file itself stays on the farmer's computer. That line is called a registration. The farmer hands the file to a lab. The platform writes a second line, a transfer listing the sender, the receiver, and the registration it points back to. The fingerprint hasn't changed. The custody has. The lab processes the file and produces a new one. The new file has different content, so a different fingerprint. There is nothing in the new file that points back to the old one. The fingerprint match alone won't reach across the change. So the lab writes a third kind of line, a declaration listing the input file, the output file, and the operation that produced one from the other. The chain extends. An advisor combines the lab's output with two other source files into one report and writes a fourth kind of line, an integration, listing every source that went in. 4 kinds of lines on one shared log: registration, transfer, declaration, integration. That is everything the platform writes. The rest of this video shows how, as a user, you put them there and read them back. The first time you open the platform, your browser generates a key pair. The public key identifies your account on the network. To sign in, the platform sends a one-time challenge and your device signs it with the private key. The key itself never moves. There is no password to steal and no administrator who can act in your name. To find a file, type the question in plain English. Show me soil files registered in this region. Show the path of this file. What sources went into this combined report? The platform reads the question, runs the right operation against the shared log, and returns the answer, with a graph where the answer is a chain. The language model that reads your question runs on your own machine, so the question itself does not leave your computer. When you find a file you want, you send a request to its owner through the platform. The owner sees who is asking and approves or declines. If they approve, the file is delivered to you, and the handoff is written to the shared log as a transfer. This replaces the usual mix of email, phone calls, and shared spreadsheets that surrounds data exchange. The record of who shared what with whom is kept in one place anyone on the network can read. What's on screen is the verification finishing successfully. A file passed through 3 organizations and arrived at the receiver byte for byte identical to the original registration, confirmed against the shared log without contacting anyone earlier in the chain. So an insurer can verify a yield report on their own. A buyer can confirm a soil sample before paying. The chain of trust no longer depends on whoever is currently reachable. What's on screen is the trace returning a full processing history. The platform walked the declarations backward through 2 transformations and reached the original registered input. Across organizations, the receiver had never spoken to. So an auditor can review a derived dataset's lineage even when every intermediate processor is offline. An AI team can confirm the provenance of every training input. The history travels with the file, not with the people who made it. What's on screen is the inspection of a combined report. 3 sources went into it, 2 registered on the shared log, 1 not. The platform shows all 3 side by side, with each one's registration status openly. So a buyer of a combined dataset sees X,